So in the females, it is different, and how it's different is that at about 5 months in the intrauterine of intrauterine life, when the fetus is about 5 months old, all the oogonia, which are shown over here, they become meiotically active. Instead of being mitotically active, all of them start going into committing themselves to meiosis. And this completes at birth, that all the oogonia are converted into a primary oocyte. And at birth, from 5 months of intrauterine life till birth, there are no oogonia left inside the ovary of the fetus. All of these oogonia have either converted into a primary oocyte or they have died. So at birth, there are no oogonia in the ovary of the fetus. All of them have become primary oocytes. The primary oocytes, they enter the first meiotic division and they reach up till the prophase of the first meiotic division, and then they get arrested. They are frozen there in time, and they stay there in that state until puberty. Now at puberty, one of these primary oocytes, it gets unarrested and it goes through the first meiotic division as shown here and gives the first polar body and a secondary oocyte. And this secondary oocyte is what is ovulated. And it goes up till the metaphase of the second meiotic division. Excuse me. And then it gets arrested once again. And it stays there, it's frozen there in the second meiotic division, in the metaphase of the second meiotic division. This secondary oocyte, this first polar body, it dies, it's finished. Now what you're left with is a secondary oocyte, which is arrested in the metaphase of the second meiotic division. Now if this ovum is fertilized by the sperm, when fertilization occurs, when it is fertilized by the sperm, it completes the second meiotic division. It gives off the second polar body, and this gamete it fuses with the nucleus of the sperm and it forms the zygote. If it is not fertilized by the sperm, it will remain a secondary oocyte and it is lost outside the body in menstruation. It will never complete its second meiotic division unless fertilization occurs. It will be lost, it will die as a secondary oocyte if it is not fertilized. So these are the significant differences. I will summarize it once again, that all the oogonia from 5 months of intrauterine life to birth convert into the primary oocytes, and they get arrested in the prophase of meiosis, or the diplotein stage. It's also called the diplotein stage of meiosis, and is to remain there until puberty. After puberty, one of these, every month, which is the monthly menstrual cycle, every month one of these primary oocytes, it gets unarrested and it undergoes the first meiotic division, and it forms the secondary oocyte shown here, right here, and the first polar body first polar body, it dies. The secondary oocyte enters the second meiotic division and is arrested in the metaphase of the second meiotic division, and it will stay there until and this is what is ovulated. Ovulation occurs, and this ovum, when it reaches the fallopian tube, the fimbriated end of the fallopian tube, then if it is fertilized by sperm and fertilization does occur, it will complete the second meiotic division, giving off this gamete and the second polar body. The second polar body dies, and the gamete, the ovum, it fuses with the nucleus of the sperm, and the zygote is formed. If fertilization does not occur, it will remain as a secondary oocyte and is lost in menstruation, and it dies as a secondary oocyte. So these are some of the significant differences between male and female gametogenesis.